Welcome. So in this lesson, we are going to go through factors and multiples. So let's start by looking over our learning intentions to know what factors and multiples are, to be able to find factors of a number, to be able to find multiples of a number, to understand that each number has infinitely many multiples. Let's begin by talking about what factors are. Factors of a particular number are numbers that divide exactly into that number. For example, the factors of 20 are 1, 2, 4, 5, 10, and 20. So in other words, these numbers right here divide exactly into 20. The factors of 20 can be found by considering pairs of numbers that multiply to give 20, which are 1 and 20, 1 and 20, 2 and 10, 2 and 10, and 4 and 5, 4 and 5. What we also have to take note of is that every whole number is a factor of itself, and also 1 is a factor of every whole number. So that is very important, and you can actually see this for this example right here. The factors of 20, you've got 1, and you also have 20, and that's always going to be true for every number we find factors for. Always 1 and the number itself, will be factors. So let's now go through some examples here. It says find the complete set of factors for each of these numbers. The first one that we've been given here is we need to find the factors of 18. So just like above, if we just find all the pairs of numbers that multiply to give 18, we can find what all the factors are going to be. So 1 times 18, 2 times 9, 3 times 6. Now 4 times what gives me 18? The answer is nothing, so it doesn't count. How about 4, 5? Does 5 times anything work? Nope. And then if we go 6, it would be 6 times 3, right? And that's just what we've got up here. So that means we stop. Once we've done it like this, the way that we write it out is we go 1 pairs up with 18, 2 pairs up with 9, 3 pairs up with 6. Whoops. And that will be our answer. 1, 2, 3, 6, 9, 18. Let's do the next one. So this is now 42. So again, what we're going to do is we're going to think of all the numbers that I can multiply together to get 42. So 1 and 42. 2 times what will get me 42? That's going to be 21. What about 3? 3 times what gets me 42? Well, if we're not quite sure, we could always just divide here. 3 goes into 4 once, with a 1 left over. 3 goes into 12 4 times. So that means 3 times 14 is going to be my answer. How about 4? 4 times what would get me 42? If we're not quite sure, we could come over here. We could do this. 42, 4 goes into 4 once. How many times does 4 go into 2? Well, it doesn't go in at all. And what would end up happening here is we would have to do something like this, like this, like this, and you'd find out it's 10.5. Now, the problem with this is that if it's 10.5, that means it didn't divide exactly. What it means is to divide exactly is we don't have any decimals. So that means that doesn't work. 4 isn't a factor. So we skip 4, we go 5. 5 times what would give me? Nothing. 5 would be 5, 10, 15, 20. I'm never going to get to 42. So let's get rid of that. How about 6? Well, 6 times 7 would work. And we can stop there. And let me show you how you know that you can stop there. So if we write them out, we'll go 1 pairs up with 42, 2 pairs up with 21, 3 pairs up with 14, 6 pairs up with 7. Hopefully you can see here, and let me get another color. I have 1 and 42, 2 and 21, 3 and 14, 6 and 7. Could I get any numbers between 6 and 7? Well, no, because, there are no numbers that exist between 6 and 7. So that means I'm done. These are going to be all my factors. Let's rub this all out, and let's highlight our answer. So you're probably thinking to yourself, well, is there a quicker way of finding factors instead of just multiplying like this? And there is. Another way to go about it is to do this. remember, you always start with 1 and the number itself, because 1 times 16 is 16. Then we'll go 2. 2 times what would give me 16? That'll be 8. So 2 and 8 get paired up. 3 doesn't go into 16, but 4 does, and it would be 4 times, well, it would be 4 times 4. And that means we're done, because there is no numbers between 4 and 4. So that means I'd have 1, 2, 4, 8, 16. That would be my answer. Let's do it again. So let's do it again and use this quick way. So we come over here. Now we're dealing with 20. So I'm going to get 1 and 20, 2 and 10. Then I would get, well, 3 doesn't go into 20, so I skip 3, 4 and 5. And hopefully you can see 4 and 5, what numbers exist between 4 and 5? No number, they're right next to each other. So that means 1, 2, 4, 5, 10, 20 is going to be my answer. Let's highlight that. All right, 2 more. 17 is an interesting example because the only 2 numbers that you can get from 1 and 17, the only factors are going to be 1 and 17. Because if you think about it, 1 times 17 are the only 2 numbers you can multiply to get 17. There is no times tables results that get you 17 out. So that just means 1 and 17 is going to be it, because the only times tables would be 1 and 17 that works. Perfect. And then lastly, 24. So again, let's use our technique here. 1 and 24. 2 and 12. 3 and 8. 4 and 6. And I know 5 doesn't work because 5 doesn't go into 24. So that's going to be my answer. 1, 2, 3, 4, 6, 8, 12, 24. Let's highlight that. Perfect. Let's come down here now and let's go through what multiples are. So you have to know what factors are. So we've covered that. Now it's multiples. Okay, so let's get out a highlighter. Multiples of a particular number are numbers created by multiplying the particular number by any whole number. For example, the multiples of 2 are 2, 4, 6, 8, 10, 12, and on and on and on. Other numbers that are multiples of 2 are 48 and 104. There is an infinite number of multiples. So this is really important. I want you to highlight that line, and I also want you to underline it. There are an infinite number of multiples. And if we think about this for a moment, I've just kind of drawn this over here. So the multiples of 2. So as it says here, numbers created by multiplying the particular number, so in this case 2, by any other whole number. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. It goes on forever. There are an infinite amount of multiples. And the great thing about multiples, whenever I think of multiples, I just think of my timetables. You just think of your timetables. They're really just saying your timetables. That's really what we're doing here. So as we come down here, it says, so we're finding multiples now. Write down the first 6 multiples for each of these numbers. So for 5, it would be 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. And that's 1, 2, 3, 4, 5, 6. They're my first 6 multiples. It's just your times tables. You just need to make sure that you include the number itself. Because think 5 times 1 is 5. So make sure you include that. So you can always figure out what the first multiple is. You're always going to include the number itself. So as we come over here, write down the first 6 multiples of 7. We're going to start with 7, then 14, then 21, then 28, then 35, then 42. So again, I'm really going to stress this. We've got 7, you got 7 here. You got 5, we've got 5 here. You always start with that number itself. Let's go through 2 more examples here. Maybe you want to pause the video and see if you can do it for 15. So it's going to be 15, 30, 40, 5, 60, 75, 90. 1, 2, 3, 4, 5, 6. And once again, let me stress 15. And last but not least, 21, 21. So now what I'm going to do is I'm just going to plus 21 each time. So 21 plus 21 is 42. 21 plus 42 is 63. 63 plus 21 is 84. 84 plus 21 is 105. 105 plus 21 is 126. And again, let me stress, 21, the first multiple is 21. So with multiples, there are two things you need to know. That they're created by multiplying the particular number by any whole number, and there's an infinite number of them. Okay, the last thing I want to go through here is the difference between multiples and factors. So factors are less than or equal to the particular number being considered. So factors are less than or equal to the particular number being considered, and multiples are greater than or equal to the number being considered. All right, so for this one right here, if we're thinking of 12, the multiples of 12 are going to be numbers equal to or greater than 12. So 12, 24, 36, 48, they're in the multiples. But factors are going to be less than or equal to 12. 1, 2, 3, 4, 6, 12. For each of the following numbers, state whether they are factors, multiples, or neither for the number 60. So we know that if it's less than 60, it could be a factor, and if it's greater than 60, it could be a multiple. All right, so 120 is greater than 60, so that means it could be a multiple, and it is. 60 times 2 is 120, so this is going to be a multiple. 14, well, that's less, so it could be a factor, but it's not, because 60 divided by 14 doesn't go perfectly, so this is neither. 15, well, that's less than 60, so it could be a factor, and it is a factor. 60 divided by 15 goes in perfectly, so that means this is a factor. 40 does not divide neatly into 60, it's less, so it could be a factor, but it's not, so it's nothing, nothing. So hopefully you get the kind of gist of it now. So 60 would be a factor, 5 would be a factor, 240 would be a multiple, 2 would be a factor, 600 would be a multiple, 100 would be neither, because even though it could be a multiple because it's bigger, 60 times nothing gets you 100. 1 would be a factor, and then the last one's a bit of a trick, it's 60. If you look here at this example when we're dealing with 12, as you can see, 12 is a factor and 12 is a multiple. So that means it's both a multiple and a factor. All right, and that's it. So hopefully you found this useful and you now have a good understanding of what multiples and factors are.